Good morning to all. In previous class, we have studied about electric field and the electric field due to a single charge at any point in space. But if in a system more than one charge is present, then how will you find a net electric field at a point? And the solution is the superposition principle. This is a very common principle whenever we have to find out the resultant of vectors. We can use superposition principle. Now, first of all, see this figure. There is a system of four charges. One is Q1, other is Q2, Q3 and Q4. Their positions are different. Now we wish to find out the net electric field at point P. So what will we do? We will find the electric field intensity E1 due to charge Q1 at P, electric field intensity E2 due to charge Q2, electric field intensity E3 due to charge Q3 and electric field intensity E4 due to charge Q4. Now you can see that E1, E2, E3 and E4 all are vector quantities and they are having different directions. So what will be the net electric field? The net electric field, according to this rule, electric field intensity due to a system of charge at a point is equal to vector sum of individual electric field intensities. Means E1, E2, E3, E4 ये इंडिविजुअल इलेक्ट्रिक फील्ड इंटेंसिटीज हैं और अगर आपको नेट इलेक्ट्रिक फील्ड फाइंड करना है तो हमें इनका क्या करना पड़ेगा? वी हैव टू टेक their vector additions, and whenever we have to take vector addition we generally use triangle rule of vector addition or parallelogram law of vector addition, and we can use resolution method. We can resolve different vectors into rectangular components and then we can find resultant. Okay, so now while calculating electric fields it must be clear to you that when I am calculating electric field at P due to Q1, then Q2, Q3 and Q4 they do not affect the value of electric field even at point P. It must be clear to you. So presence of other charge do not affect the value of electric field intensity at a point. So it is written here. It must be noted that electric field intensity at a point due to a charge is not affected by presence of other charges. So when we are calculating E1 it means it is purely because of Q1. When we are calculating E2 it is purely because of Q2, and by calculating all electric field intensity we will take their vector sum, and this vector sum will give you the net value of electric field intensity. Okay, so this is the general expression. Now come to the next point. This is if a metal is placed in external electric field, what will be its behavior? Okay, so we are taking a piece of metal. This is a rectangular piece of metal and we have placed it in an electric field, external electric field E0. E0 is the external electric field we have applied. Now if we talk about inner structure of, or we can say inner arrangement of electrons inside a metal, it is very clear that metals have free electrons, and these electrons they are free to move anywhere within the metal. They move with different velocities. Okay, and their motion is always random, but if we calculate average of the velocities it is always equal to 0, that there is no net motion of electron. That is why in a conductor there is no electric current inside it still till we connect it with a source of EMF. So if there is a pure conductor, electrons are moving inside the conductor but there is no net motion, hence there is no net current. So average of the velocity is equal to 0. But as soon as I apply this external electric field, then what will happen? ये हमने स्टडी किया है ऑलरेडी कि जो चार्जेस हैं उनको अगर आप इलेक्ट्रिक फील्ड में रखते हैं then they experience electrostatic force of attraction or repulsion. Positive charge experiences force along the electric field and negative charge experiences force opposite to the electric field. It means if this is the direction of electric field, electrons will experience a force opposite to electric field. So when a metal is placed in an external electric field E0, electron experiences drift force. Magnitude देख लें, direction opposite होगी. Magnitude is E0 and this is opposite to direction of E0. If electric field is applied in this direction, the force on electron, it is opposite direction, it means in left hand side. Okay, so electron start drifting opposite to the external electric field. Now what will happen? These electrons get accumulated in left hand side. So when electrons get accumulated in left hand side, positive charge get developed at right hand side. Now accumulation of this charge, plus charge in right hand side, minus charge in left hand side, it will develop internal electric field, or we can say electric field inside the metal, and this is just because of accumulation of these charge, or we can say this is because of drifting of electrons opposite to electric field, external electric field. Now what is the role of this internal electric field? This electric field will oppose the drifting of electrons. Now you can see I have mentioned it here. Electron start shifting opposite to the direction of external electric field, so all the free electrons get accumulated in one side of metal. So deficiency of electron on other side, means right hand side, creates positive charge. Due to the accumulation of charges, an electric field get developed inside metal. The role of this electric field, internal electric field, is to oppose the drifting of electrons. Now due to the accumulation of charge, value of E, internal electric field, goes on increasing. Okay, now a situation comes when two forces, the force on electron due to external electric field and the force due to internal electric field, it is equal but opposite in direction. In that case, net force is 0, then electron stop drifting. You can see, if you talk about electron, this is external electric field, so force on electron is in this direction. This is internal electric field, so force on electron, it will be in this direction. When this electric field is balanced by E0, you can see E is equal to minus of E0. When this electric field is balanced by external electric field, net force or net electric field inside the metal becomes 0, because internal external field and external electric field, they counterbalance each other. So drifting will be continue till the internal electric field becomes equal and opposite to external electric field. In this case, or at this situation, the flow of electron get stopped. Okay, so this will be the last or equilibrium stage. When force due to external electric field E0 is equal to force due to internal electric field EE, then electron stop drifting. In this situation, net electric field inside a conductor is always 0, or we can say net force on the electron is also equal to 0. So this is the behavior of metal when placed in an external field, that when metal is placed in an electric field, net electric field inside the metal becomes 0. I think it is clear to you. Next, one important phenomena, that what is the direction of electric field near the surface of a metal. So it must be clear to you that electric field lines, or we can say electric field intensity, direction of electric field intensity, it is always perpendicular or normal to the surface. If this is metal surface, electric field must be perpendicular. So how can we verify it? Let us suppose that it is not perpendicular. कुछ फिनोमेना ऐसे हैं जिन्हें हम डायरेक्टली प्रूव नहीं कर सकते, हम उसका जस्ट ऑपोजिट एज्यूम करते हैं और फिर उसको हम ये प्रूव करते हैं कि अवर फिनोमेना इज रॉन्ग, तो ऑटोमेटिकली वो 90 डिग्री अप्रूव हो जाएगा. सो लेट इलेक्ट्रिक फील्ड इंटेंसिटी नियर द सरफेस इज नॉट परपेंडिकुलर. आई हैव टेकन इट, यू कैन सी दैट आई हैव टेकन इट एट एन एंगल थीटा. अब अगर इलेक्ट्रिक फील्ड एक थीटा एंगल पर है तो उसको रिजॉल्व कर लें. इलेक्ट्रिक फील्ड, द कंपोनेंट along the metal surface E cos theta, and component perpendicular to metal surface, this is E sin theta. ओके नाउ आपको ये पता है मेटल है, इलेक्ट्रॉन्स होंगे, चार्ज होगा, बट चार्ज कैनॉट लीव द मेटल सरफेस. इट मीन्स ई साइन थीटा का कोई रोल नहीं है, क्योंकि ई साइन थीटा की जो डायरेक्शन है दैट इज परपेंडिकुलर टू सरफेस. बट व्हाट इज ई कॉस थीटा? द डायरेक्शन ऑफ ई कॉस थीटा इट इज अलोंग द सरफेस. इट मीन्स अगर ये डायरेक्शन है इलेक्ट्रिक फील्ड की, तो इस डायरेक्शन में फोर्स भी होगा. ओके now I have resolved electric field into rectangular components. Now hence charge will experience a force equal to, what is the formula for force? Force is equal to charge into electric field. Charge is q, electric field is E cos theta. ड्यू टू दिस फोर्स चार्जेस विल स्टार्ट मूविंग. क्योंकि चार्ज है, चार्ज पर अगर फोर्स लगेगा, मेटल सरफेस के अलोंग है, तो चार्जेस मेटल सरफेस के अलोंग मूव कर सकते हैं. बट इन इलेक्ट्रोस्टैटिक्स the net force on charge is equal to 0. It means QE cos theta must be equal to 0. Here Q is not equal to 0, it means cos theta is equal to 0. If cos theta is equal to 0, then theta is equal to 90 degree. It means theta 90 means the electric field intensity E is always normal to surface, but this condition is always near the surface only. As we move away from the surface, the electric field intensity may change its direction, but near the surface electric field lines are always perpendicular to surface. The next important topic, the electric field lines and its properties. Now a question arises that how can we visualize electric field intensity? Just to visualize electric field intensity, we have electric field lines. These electric field lines are completely imaginary, and these electric field lines are drawn just to visualize the electric field intensity or effect of electric field intensity. Okay, what is the direction of electric field lines, electric field intensity? What is the strength of electric field intensity? It is represented by electric field lines. Okay, now electric field lines are imaginary. Second thing, electric field lines may be straight and electric field lines may be curved. ये दोनों चीजें पॉसिबल हैं. इलेक्ट्रिक फील्ड लाइंस स्ट्रेट भी हो सकती हैं और इलेक्ट्रिक फील्ड लाइंस कर्व्ड भी हो सकती हैं. इट डिपेंड्स ऑन द नेचर ऑफ चार्ज एंड सिस्टम ऑफ चार्जेस. सो हाउ विल वी ड्रॉ दीज लाइंस? आप क्या करेंगे, एक इलेक्ट्रिक फील्ड रीजन लेंगे और उसमें किसी भी एक पॉजिटिव चार्ज को प्लेस करेंगे, और प्लेस करने पर उस पर फोर्स अप्लाई होगा, और उस फोर्स के कारण वो चार्ज जिस डायरेक्शन में मूव करेगा, जिस पाथ के अलोंग मूव करेगा, दैट पाथ इज बेसिकली द इलेक्ट्रिक फील्ड लाइन. सो इलेक्ट्रिक फील्ड लाइंस आर इमेजिनरी, straight or curved path along which a positive charge tends to move when free to do so in an electric field. Okay, so its movement depends on strength of electric field. So we say that it tends to move. Its movement is not compulsory, but it tends to move along a path when placed in an electric field. That path followed in an electric field is electric field line. Now, if the charge is single, then electric field lines are always straight. But if there is a group of charges, then electric field line will be a curved line. So for a single charge, electric field lines are straight, and for group of charges, field lines are curved. Now let us start its properties. Now it must be clear to you that degree of closeness of field lines, it represents the strength of electric field. If lines are comparatively close, then field will be stronger. If the lines are separated or lines are diverging, the electric field strength will be less. Now, first property. If we talk about positive charge, electric field lines are straight and radially outward. It means for positive charge, field lines will originate from positive charge and they will go to infinity along the radius. Similarly, for negative charge, field lines are again straight and they are radially inward. You can see this is the positive charge and field lines are moving along the radius and they are moving towards infinity away from the positive charge. Okay, but for negative charge, field lines coming from infinity and they are terminating at negative charge. So we can say field lines originate from positive charge and ends at negative charge. This is the first basic property. Now, second thing, suppose you are having a curved line. We are having 2 points. If I draw a tangent at this point, this tangent will give you the direction of electric field at that point. This is another point, again draw a tangent. This is the direction of electric field at this point. Okay, but in a region, अगर ये हम मान लें कि ये एक इलेक्ट्रिक फील्ड का रीजन है, तो इसके एक पर्टिकुलर पॉइंट पर इलेक्ट्रिक फील्ड की सिंगल डायरेक्शन होगी, 2 डायरेक्शंस पॉसिबल नहीं है. ओके, फॉर एग्जांपल एक आगे टॉपिक आएगा, 1 लाइन एंड 2 लाइन, दिस इज द पॉइंट ऑफ इंटरसेक्शन. अगर मैं इस टेंजेंट को फॉलो करता हूँ, दिस इज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. अगर मैं इस टेंजेंट को फॉलो करता हूँ तो ये इलेक्ट्रिक फील्ड की डायरेक्शन है. 2 डायरेक्शंस पॉसिबल नहीं है. सो देयर कैन नॉट बी 2 डिफरेंट डायरेक्शंस ऑफ इलेक्ट्रिक फील्ड एट 1 पॉइंट ऑफ रीजन. डिफरेंट पॉइंट्स पर डिफरेंट डायरेक्शंस हो सकती हैं, बट एक पॉइंट पर 2 डायरेक्शंस पॉसिबल नहीं है. द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड इज ऑलवेज यूनिक एट ए पॉइंट. सो इसी फिनोमेना को ध्यान में रखते हुए हम ये भी प्रेडिक्ट कर सकते हैं that no two field line intersect each other. They can attract each other, they can repel each other, but they cannot intersect each other. Why? If it is so, अगर ऐसा होता है, then there will be 2 tangents. आप देखें ये point of intersection है. इस point of intersection पर आप 2 tangent draw कर सकते हैं. One along this curved path, another along this curved path. So we can draw 2 tangents and 2 directions of electric field at that point, which is not possible. So 2 lines cannot intersect each other. Second thing. Now, electric lines of force are discontinuous curved in electrostatic condition. They do not form a closed path. Closed path का फॉर्म होता है कि जिस पॉइंट से आपने स्टार्ट किया, लाइंस अगर वहीं पर आकर के टर्मिनेट हो, then they are said to be forming closed path. But what happens in case of positive charge? Electric lines of force start from charge and goes to infinity. It means they are not forming a closed loop. If we talk about negative charge, they are coming from infinity and terminate at negative charge. Okay, but अगर मैं combination ले लूँ positive and negative का, then electric field lines will start from positive and they will end at negative, but there is no lines of force from starting from negative and terminating at positive. Okay, so line start हो रही है, end हो रही है, but ये closed loop का formation नहीं करती है. So electric field lines are discontinuous and they do not form closed loop. Okay, the most important thing to learn: if electric lines passes through a region where there is no charge, field lines are continuous without any break. It means lines पास हो रही हैं ऐसे रीजन में जहाँ कोई चार्ज नहीं है. इसका मतलब ये है वहाँ से कोई लाइन ना तो ओरिजिनेट होगी, वहाँ पर कोई लाइन ना ही टर्मिनेट होगी. इसलिए किसी भी इलेक्ट्रिक फील्ड लाइन में ब्रेक पॉसिबल नहीं है. वहाँ से लाइंस कंटिन्यूसली पास होंगी. द रीजन इज if in that region, if there is positive charge, then electric field line will originate from that point. If there is any negative charge, then electric field line will terminate at that point or terminate in that region. But if there is no charge in any region, field lines will pass through that region continuously. Okay, So if field lines pass through a region having charges, then field lines may originate in case of positive charge and may terminate in that region. क्योंकि नेगेटिव चार्ज में लाइंस आकर के नेगेटिव चार्ज पर एंड होती हैं, और अगर पॉजिटिव चार्ज होता है तो लाइंस वहाँ से ओरिजिनेट होती हैं. सो अगर दोनों ही चार्ज नहीं हैं तो जो इलेक्ट्रिक फील्ड लाइंस आएंगी वो इस रीजन को कंटिन्यूसली पास करेंगी, न तो उस रीजन में टर्मिनेट होंगी, ना ही उस रीजन में ओरिजिनेट होंगी. This is the important thing. Now you can see if there are unlike charges, obviously they attract each other. If they attract each other, electric field lines also attract each other. Then due to the force of attraction, field lines may contract, means they may come closer along the length. You can see these are the lines and they are coming closer to each other along the length because of force of attraction. But if the charges are like charges, then due to the repulsion, and whenever repulsion is there, lines will repel each other, and when they repel or oppose each other, they feel lateral pressure on each other. Electric field lines may apply lateral pressure on each other. You can see this is positive charge, this is positive charge. The direction of field lines are opposite to each other, so they will repel, and because of the repulsion they get bent in this way. Okay, they are not moving, they are not tends to move towards each other, they are opposing, and because of the opposition ये लाइंस जो हैं इस टाइप से बैंड होती हैं. Okay, the number of electric lines, it represents the strength of electric field, and already we have studied that inside a metal net electric field is 0. So what are the number of electric lines inside a metal? Obviously it is also 0. It means no field line pass through a metal, as net electric field inside a metal is 0, hence field lines do not pass through a metal. मेटल से पहले भी इलेक्ट्रिक लाइंस होंगी, मेटल के बाद भी इलेक्ट्रिक फील्ड लाइंस होंगी, बट इनसाइड द मेटल देयर इज नो इलेक्ट्रिक फील्ड लाइंस. Okay, so electric field lines do not pass through a metal. And the last and the simplest property, that field lines are always perpendicular to the metal surface close to it. Okay, near the surface metal जो field lines हैं they are always perpendicular to it. आप एक चाहें तो 9th प्रॉपर्टी और ऐड कर सकते हैं, that degree of closeness of field lines, it gives the idea about strength of electric field. लाइंस अगर क्लोजर हैं तो इलेक्ट्रिक फील्ड स्ट्रेंथ स्ट्रॉन्ग होगी, और अगर लाइंस अगर सेपरेटेड हैं तो इलेक्ट्रिक फील्ड की स्ट्रेंथ लेस होगी. यू कैन ऐड एट योर ओन लेवल. So this is the completion of topic electric field lines and their properties. Now let us introduce a small topic. जो डिटेल स्टडी है वो हम कल की क्लास में करेंगे, नेक्स्ट क्लास में करेंगे. अभी हम सिर्फ एक इंट्रोडक्टरी आइडिया ले रहे हैं, एंड दैट इज अबाउट इलेक्ट्रिक डाइपोल. डाई मीन्स टू, पोल मीन्स पोलरिटी. Two opposite polarities, they are placed at very small distance, and we are dealing about electric dipole. It means opposite polarities are created by two charges. So when two equal and opposite charges, they are placed at very small separation, they are said to be formed an electric dipole. एक पॉजिटिव चार्ज ले लें, एक नेगेटिव चार्ज ले लें, और उनको एक कॉम्बिनेशन में एक शॉर्ट डिस्टेंस पर प्लेस कर दें, तो उस केस में एक डाइपोल का फॉर्मेशन होगा. यू कैन सी ए नेगेटिव चार्ज माइनस क्यू, एक पॉजिटिव चार्ज प्लस क्यू, सेपरेशन इज 2a, so this is an electric dipole, and line joining these two charges is called axis. तो फिर आप इसके लिए क्या कर सकते हैं, अगर मैं इन दोनों चार्जेस को ऐड करूं तो क्या रिजल्ट मिलेगा, माइनस क्यू एंड प्लस क्यू, रिजल्ट विल बी 0. सो वी कैन से फॉर एन इलेक्ट्रिक डाइपोल Q1 प्लस Q2 इज इक्वल टू 0. ओके, बहुत सारे एग्जांपल्स हैं, आप केमिस्ट्री में देखते हैं बहुत सारे. अभी नेक्स्ट टॉपिक में हम इसी को स्टडी करेंगे कि डाइपोल्स कौन कौन से हैं, कैसे इनका फॉर्मेशन होता है. बट किसी भी फॉर्म में हो, चार्जेस इक्वल होने चाहिए एंड उनकी पोलरिटी ऑपोजिट होने चाहिए. मीन्स एक पॉजिटिव होगा और एक नेगेटिव होगा. चलिए नेक्स्ट आता है डाइपोल मोमेंट. डाइपोल मोमेंट का फिनोमेना क्या है. ये एक्चुअली डाइपोल की स्ट्रेंथ को रिप्रेजेंट करता है। व्हाट इज द स्ट्रेंथ ऑफ ए डाइपोल? द स्ट्रेंथ ऑफ ए डाइपोल इज रिप्रेजेंटेड बाय डाइपोल मोमेंट। अब इसकी वैल्यू कैसे फाइंड करें? इट्स मैग्नीट्यूड इज इक्वल टू प्रोडक्ट ऑफ मैग्नीट्यूड ऑफ आइदर चार्ज एंड डिस्टेंस बिटवीन देम। मतलब आप किसी भी चार्ज को ले लें और उसको दोनों चार्ज के बीच का जो सेपरेशन है 2a उससे मल्टीप्लाई कर दें, सो इट विल गिव यू magnitude of dipole moment. Dipole moment is represented by small p. It is a vector quantity. Its magnitude is q into 2a. 2a is the total separation between two charges. I have mentioned it here क्योंकि distances origin से ली जाएंगी, तो इस साइड में भी distance a है, इस साइड में भी distance a है, then total separation becomes 2a. Now, if we talk about unit q, charge is measured by coulomb and separation is measured by meter, so its unit becomes coulomb meter. And the important thing about direction, it is a vector quantity and its direction is always along from negative charge to positive charge. आप देखें ये my नेगेटिव चार्ज है, ये पॉजिटिव चार्ज है, तो नेगेटिव चार्ज से पॉजिटिव चार्ज की तरफ जो डायरेक्शन है दैट इज द डायरेक्शन ऑफ डाइपोल मोमेंट। ये डाइपोल मोमेंट हमने इंट्रोडक्टरी आइडिया इसलिए दिया है क्योंकि नेक्स्ट जो क्लास होगी उसमें हमें सारा डाइपोल मोमेंट और डाइपोल मोमेंट के कारण डिफरेंट पॉइंट्स पर इलेक्ट्रिक फील्ड इसके बारे में स्टडी करना है। तो उससे पहले आप इसको थोड़ा सा अच्छे से रिवाइज कर लें कि डाइपोल क्या है, उसके बाद नेक्स्ट टॉपिक आपको अच्छे से क्लियर होगा। हैव अ गुड डे।